A car park jet fan system is an airflow network, not a row of small fans. This engineering explainer is for MEP contractors and design consultants. It shows concepts and qualification questions, not a validated project layout, code approval, or smoke control certificate. Start by separating two operating modes. Normal ventilation manages vehicle-related contaminants. Emergency smoke control follows a defined fire strategy. They have different objectives, scenarios, controls, equipment duties, and acceptance evidence. Success in one mode does not prove the other. Trace the complete normal ventilation path. Outdoor or makeup air enters through defined openings or supply points. Jet fans transfer momentum through the occupied volume, and main extract fans and shafts discharge air safely. Jet fans do not create makeup air or replace extraction capacity. A jet fan produces thrust. Its high-speed outlet entrains surrounding air and helps move a much larger air mass along a chosen route. Use the exact tested thrust, direction, sound, power, and installation configuration. Diameter or free air CFM alone is not a reliable selection basis. Ceiling beams, signs, ducts, ramps, parked vehicles, columns, fan offset, and discharge clearance can bend or block the momentum path. A neat arrow on a plan is only a hypothesis until geometry, operating conditions, and installation effects are reviewed. Demand control is a sensing and control system. The relevant contaminants may include carbon monoxide, nitrogen dioxide, or project-specific sources. Detector listing, placement, calibration, redundancy, alarm thresholds, fault response, and staging logic must follow the governing project requirements. Now switch visibly to fire mode. Define the design fire, smoke zones, makeup path, extraction path, sprinkler and detection interactions, tenability or egress objectives, firefighter operation, emergency power, recovery mode, and failure response before judging jet fan direction or duty. Smoke duty claims require exact evidence. Verify the applicable test standard, temperature and duration rating, direction, approved accessories, cables, supports, controls, and power path. A rating from another model or configuration cannot be borrowed. Computational fluid dynamics can test airflow hypotheses, but colored contours are not proof by themselves. Review project geometry, mesh independence, boundary conditions, fan representation, ambient effects, traffic blockage, fire assumptions, sensitivity cases, and acceptance criteria. Coordinate installation before procurement. Check structural anchors, vibration, falling object protection, vehicle clearance, access, reversible operation, noise, electrical isolation, emergency power, control interfaces, and safe maintenance space. Confirm that discharge does not transfer contaminants to occupied areas. Commission the integrated system, not isolated fans. Verify fan identity and direction, main supply and extract operation, detector alarms, staged logic, status feedback, backup power, manual controls, communications, documented failure modes, and measured results under the approved procedure. Release the design only when both operating modes have traceable objectives, complete airflow paths, exact fan evidence, reviewed controls, controlled modeling, coordinated installation, and witness testing. There is no universal fan count, spacing, thrust, air change rate, sensor threshold, or smoke clearance time.